Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Reuben Saltzman. I'm your host, alongside building science geek Tessa Murry. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to the show. Welcome to the Structure Talk podcast. Tessa, always great to see you. Good to see you. Beautiful day here in Minnesota. We just got what feels like our first real snow of the season. We got some little flurries here and there, a little dusting, but today we got some plowable snow. Minneapolis declared a snow emergency. That's always my barometer if it's a good snow.
Did school get canceled?
Snow emergency
in the Twin Cities?
In some schools canceled it the day before. In my district from Maple Grove, they're letting out school just a little early.
Oh my gosh!
So it's always fun, isn't it?
Very exciting. Yeah, we have about 6 inches down here in Red Wing too, and the local schools are open, but the roads were not good. So a little treacherous out there.
Yeah. Mike Casey is our guest today. Mike doesn't know anything about this. It's this white stuff that falls from the sky, Mike.
Well, I grew up in Connecticut. We had plenty of snow back in the 60s and so on when I was there. We used to get stuck not being able to go to school or anywhere for 3 and 4 days at a time. But they don't get stuck like that anymore. And, of course, now I'm in Southern California. So, yeah, snow is not anything I have to deal with. So, actually, I got tired of building houses in the snow, which is why I moved from Connecticut, or one of the reasons, to SoCal.
Yeah.
Smart.
That's no fun. Nobody does their best work when it's cold and snowy.
No, we'd spend the first, hour or two trying to get the place warmed up when we were doing additions. We'd, drop a salamander and go get some coffee and egg on a hard roll while we were waiting for it to warm up.
Well, this is the perfect segue. This is the reason we have Mike Casey on with us again today. We've had you on before. I believe it was for a discussion about grounding and bonding. So if anybody is listening to this and they want to learn more about electricity, that's a great podcast to go back to. But we've got you on again because you're in a, quote, hot, dry climate these days. This is the first episode of a multi-part series that Reuben and I are doing again this year, talking to experts from different regions around the country to dive into, what's their housing stock like? What are some building science problems they have? What are some other challenges they run into as home inspectors? And we just want to get a different perspective because we're in our little bubble up here in the tundra right now with the snow flying around. We know our area really well, but we've got listeners all over the country and curious people, and we want to dive into some of these things that you see on a regular basis that we can't speak to. So we're honored to have you on today and really excited to dive in.
Yeah.
Thank you,
For anybody that doesn't know, for anybody that doesn't know Mike Casey, do you want to do just a brief introduction, Mike, of who you are?
Sure. Well, it's, Mike Casey. I do live in Southern California, in the San Diego area. And back long time ago, my first trade was a plumbing and mechanical contractor in Connecticut. And mid-'80s or so, I decided, like I said before, I'm a little bit tired of building houses in the snow. And moved to Southern California, where I got into home inspection almost 40 years ago. And I've had a home inspection company. We do homes and commercial inspection, a lot of insurance consulting, and legal work. And that's what I've been doing for almost the past 40 years. And it's been a fabulous profession, and I've enjoyed it and seen a lot of different things, especially here in this climate that we have in San Diego. We've got coastal, which can be wet and a lot of fog at times. We've got, in the middle, kind of the hot or warm and dry. And then in the desert, we've got certainly hot and dry. And then we also have the mountainous areas where we're going to get some snow pretty soon. And that's about 20 minutes from my house. So,
oh my gosh, you've got it all.
Yes, we do here. So there's lots of different things that we're seeing. And that's a little bit about me. I've done a lot of things with inspector associations, and currently I'm on the board of the Examination Board of Professional Home Inspectors. And that's what's keeping me busy. I'm traveling around the country, speaking to inspectors at different conferences. It's been a lot of fun.
Well, you're extremely humble, Mike, but I think you obviously have made a career out of, learning through other people's mistakes and helping us all be better. And you are one of the best teachers I think I've ever run across. So whenever I get an opportunity,
well, thank you.
whenever I get an opportunity to listen to you or to listen to a class of yours, I always try to. But we're excited to dip into some of your knowledge and experience today. And if we happen to meander to some of these other climate zones with things that you see or have experienced, we can do that too. But today's focus is on hot and dry climates, and we'll have other guests on to represent different climate regions too later on. So stay tuned, listeners. Shout out though to Paul Starin, who we had on last year for our hot dry representative, and he was wonderful. And some of the things that he was talking about that was very interesting to hear about was the challenges they have. They don't have all the moisture and the rain and the snow that we have here, but they do have some other challenges. And some of that he was talking about kind of the slabs and just the structure of that and making sure that they're not having shifting, cracking, structural concerns with that. He talked to us about post-tension slabs, which was something new that I didn't know much about, which is a kind of a method, I guess, of keeping that slab more stable. And he also talked about, too, some of the challenges with like having to inspect pools, because a lot of houses have pools, and that's something we don't really see a lot here in Minnesota, obviously. For the 1 month a year, you could use it. And he also talked about, cooling is obviously the main kind of system in the house that they're testing and looking for issues with. And that, a lot of cooling systems are either located in the attic or on the roof or outside or something like that. And just making sure that the cooling system is working properly. Now, we talked about some other details, but those are kind of the highlights that I remember. So I'd love to kind of dive into some of these things a little bit more and maybe kind of talk to us a little bit about, he also mentioned too, the housing stock is typically newer, at least where he was in Phoenix, Arizona. It was like 1950s is kind of the oldest that he sees. Now, I don't know. Do you have older housing stock where you are in California that's prior to 1950s that has its own, old house issues?
Well, we do. And an old house here in Southern California is probably going to be from the 20s. So that was what we would call older housing stock. And most of those are crawl space, old, certainly not tight construction. And then our newer homes are typically slabs on grade, kind of like you were just talking about and with Paul. But most of ours here are also post-tension slabs. And the main reason is we've got expansive soils, sometimes critically, sometimes just moderate or minimally. But when you have a cracked slab, even though the slab doesn't really hold anything up, it's just a place to lay your rug and walk on. The stigma of a cracked slab is horrible. So people think that the house is falling apart if there's a crack in the slab, which really might not have any structural effect. So builders here tend to use post-tension slabs because we know concrete's going to crack. That's inevitable. But we want to hold it together so you don't get, anything more than maybe 1/8 of an inch crack in it, so that people don't get all excited about it and think their house has fallen into a sinkhole. So, that's primarily the reason we use them. It does get you some credits as far as size of footings and that kind of thing. But post-tension is mainly to hold the slab together and allow it to act as kind of a mat and move around a little bit and keep it together so that you don't get large cracks that just, frankly, people think that the house is falling down when really it isn't.
So remind me, how do you build a post-tension slab?
Well, you first have to set your perimeter forms and your footing forms. And then a crew comes in and they install these greased plastic tubes. And inside of those tubes, and they run typically crossways, about 18 inches on center, the full length of the house. And inside of them is a stranded metal cable. And these pipes are greased because after the concrete is placed and gotten to its 28-day hardness, what will happen is a crew comes back and they tension up these cables with a tool and then put in a cable lock in this little cup at the perimeter of the slab, and then with a torch cut off the excess cable and then plug it with a patch mortar. And what that does is they tension those cables up to about 2,500 or 2,000 to 2,500 PSI, and that holds the slab together. So it's a pretty cool process. And every once in a while, I'll run across one where a cable has failed. And basically what you'll see is a steel cable projecting out from the edge of the concrete slab a couple of feet. Because when that thing breaks, it shoots out a little bit.
I bet.
And, Well, yeah. And you want to be careful if you're going to remodel your house and do some slab cutting or a core or whatever it is for your slab. You got to have it x-rayed first so you don't cut these things. Or if you have to cut them, you need to be prepared. So a house that's got a post-tension slab typically has an identifier stamped into the concrete in the garage that says post-tension slab, do not cut, because it's a hazard. Somebody could get hurt if they're saw cutting the concrete and cut one of those cables. Because 2,500 PSI is a lot of tension.
Yeah.
So, Mike, what do you?
It's loud.
Yeah. So what do you do if someone's like remodeling and they want to change the location of like their kitchen sink, or, they want to move some plumbing around? Are a lot of the water pipes in the slab, or are they running through the attic, or what?
We used to put the water piping embedded in or under the concrete slab, and maybe up until about the late 90s or so, we would run usually copper pipe under the slab. But modern technology now, if we put them above the slab, usually it's going to be PEX or maybe CPVC, not a whole lot of copper anymore. But the reason we put it above the slab is because, when it eventually needs repair, and if you look at a house, the typical life cycle should be at least 100 years. Some systems are going to need replacing. And if you have your water piping above the slab, it's a lot easier to get to it, of course, because you don't have to cut. Because if you have to cut a post-tension slab, you need to x-ray it first so you know where the cables are. And you may have to release tension on them. There's special ways to do that if they have to cut where the cables are located. So just something else to consider. So we go from old housing stock that's crawl space where you can see everything to these post-tension slabs where you don't know what's under it.
I'm sorry to go down a rabbit hole, but that's what this podcast is all about. We ask the questions that we find
interesting. You got me for an hour.
So you also got pre-tension slabs, and I've seen how those are done, where it's like they take a big cable like you're describing, they stretch the heck out of it, and then they pour the concrete around it. I think usually they just they let it go after the concrete has set.
Hopefully, 28-day cure. Yeah, and then you can let it go.
Yeah, and then you let it go. And but
hopefully it doesn't break anything.
And it is the reason why you'd use one over the other, isn't it that like a pre-tension slab is where you would just have maybe, I don't know, a 4-foot, 8-foot wide section that's really long, and then you'd have it shipped on site, versus post-tension is where you do the whole thing.
Right. Well, pre-tension has to be truckable.
Got it.
There's a limit.
Good way to put it.
As far as size, when it comes to putting something on a truck, you could do maybe 60 feet long, but your width is limited to about 10, 12 feet.
Yeah. Okay. All right. Got it.
Otherwise, you have trouble getting down the road or under bridges and things like that.
Yeah.
Going back to something you said, Mike, can I ask you really quick? When you said the water pipes are above the slab, can you clarify that? Does that mean they're running in the attic then?
Oh, yeah. Yeah. In our climate here, we don't have to worry too much about pipes freezing,
Okay.
unless you live in the mountains, which is pretty close to me, where it does snow and get cold. Actually, it gets cold where I live. It was 33 degrees this morning. But it's almost 80
now. That is cold.
Yeah. So we typically put them up in the attic, which, when I was building in Connecticut, we would never think of doing that because they would freeze. So lots of piping, lots of PEX we're seeing now in new construction in the attic.
Okay. So lots of PEX. Now I remember another conversation we had, I think it was with John Bolton, and we were talking about Florida, and he was talking about how they're having all kinds of problems with PEX. It's failing left and right, and they're getting all these leaks. Are you seeing any problem with PEX in your area, Mike?
Well, there's certainly problems with anything. I don't think it's as wholesale as what I've heard is happening in Florida. And some of it has to do with the type of sanitizer that's used with the municipal water supply. There's some issues with chloramine, which is a new type, not new, but a different type of sanitizer, similar to chlorine, but it's more stable. So it's something that's desired by municipalities, but it is causing some issues with PEX and also with neoprenes. It tends to not be too friendly to neoprene, which is in a lot of things that are plumbing. So I'm just not seeing wholesale failures with PEX here. I'm seeing some isolated issues where there could be bronze fittings are failing because they're too much zinc. Not enough copper could be the issue. Of course, every once in a while we get blow-offs where they just weren't installed properly. So overall, I think PEX is a pretty good system, and I've used it in a couple of additions that I've built for my own use. And it's still there. It's still working.
Okay. All right.
So is that pretty much what you see in terms of, plumbing materials being used is plastic, PVC, PEX, or do you have some other materials that you'll run into too?
Well, typically we still are seeing some copper. We're seeing occasionally CPVC because regular PVC is only approved for outdoor use for cold water. So that's irrigation. And then we're seeing PEX. So that's about it here. Not too much.
Okay.
That's really about all that. People use it pretty much everywhere, I think.
Yeah. Now, I'm curious kind of about some building envelope questions for you. I'm just curious about like the basic kind of materials that you'll typically see they use to build a standard home down there. Is it wood frame construction? Is it block? Is it a combination? What types of materials are used in the wall? All of it. Are there vapor barriers?
Sure. Happy to go through that. Typically, the typical house here in Southern California is full thickness stucco, 3-coat stucco, traditional stucco. On the outside over basically paperback lath, which is building paper. And then we have wood frame walls. Not much block here because we haven't had a major hurricane that I can remember, and I've lived here a long time. Although we do get decent rain every once in a while. So, it's not a lot, but every once in a while we get a heavy rain. So typically wood frame construction, truss style, manufactured trusses for the roof framing. And the roofs are typically going to be concrete or clay tile or asphalt shingles. So mostly tile. You'll see the red tile roofs and the cream or Navajo white colored stucco. That's our typical with a concrete slab on grade. Every once in a while we'll see crawl spaces. That's usually because it's a house that's built on a slope and it's just more economical to build it with a perimeter foundation and intermediate foundations and a crawl space rather than filling that area, that slope with concrete. So that's our typical house. The climate here is pretty forgiving. So, a lot of people here don't care that much about the HERS rating, the home energy efficiency rating system, which is part of the requirements of building new construction. Now we have what's called Title 24, which is the energy efficiency requirements here. And when you have a house plan check, you have to comply. And there are companies that just do the calculations for Title 24 compliance because there's many different ways to get that. You have to hit a certain number. And then, of course, we have lots of new ventilation requirements and so on. The issues that we see are often when it's not really from rainfall, but a lot of times what happens is people here use a lot of irrigation water. And many times they start watering their house and they don't realize it. So that introduces a lot of moisture, and that's what can cause problems. New construction, the main thing we're concerned about here is cooling. So cooling performance and limiting the solar gain in the house is probably the top priority in new construction. That along with ventilation. I know that was a long answer, so pick whatever from it you want.
Reuben and I both have a question for you. Reuben, you go first.
Okay, well, mine is just specific to the cooling system. So maybe before we jump to another topic, Tess, did you have one still on the envelope?
Well, many, Reuben. I guess
right, let's come back to me.
Good.
Okay. So, do you have vapor barriers in the exterior part? I mean, with your climate being primarily a hot climate with cooling, even though it's dry, you do get rain and stuff like that. Do your assemblies require any vapor barriers at all?
Well, typically you're not going to see the conventional plastic sheeting vapor barrier that you might be thinking of. We don't use that here. Now, underneath the stucco, we're going to have, typically it's a type 15, what some people used to call 15 pound, which it isn't anymore. But type 15 paper is behind the stucco. And if it's over wood framing, which it pretty much always is here, we're required to use 2 layers. So it provides like a bond break of the stucco from the wood, so things can expand and contract at different rates. But we don't really use vapor barriers. We use it's a liquid water barrier from outside,
right?
And then some newer construction is going to be like the air barrier material with the ridging in it that provides a drainage plane for moisture that gets behind the stucco, usually in through cracks, and lets it go out the bottom of the wall. So that's typically what we see.
Yeah,
it's a unique
that's
climate.
Helpful. Yeah. No, that's helpful. It is, like you said, more forgiving, and your wall systems don't need that vapor barrier, but you've got vapor retarders and just materials that help protect the wood wall sheathing from potential moisture.
And water intrusion from the rain when we get it every once in a while. Usually it comes with wind. And then the main thing though with the envelope is to stop solar gain or limit solar gain. So you can build there's a lot of different ways of doing it. So there's so many different calculations you can do, but typically your windows have to have a minimum U rating so that you're preventing that UV rays from getting in. But you can also do, I know the house I live in is a Palm Springs style house with a low slope roof, but the roof perimeter, it has a 3-foot overhang. So when the sun's high, what it does is it prevents the sun from hitting the windows and coming in and heating up the air in the house. Excuse me. So that's another way to do it, where you just limit. You don't let the sun actually hit your window.
Right. Design that makes sense. Yeah. Okay. Very cool. Reuben, do you want to ask your question? Oh, sorry. Looks like you're about to sneeze.
I was, but if I got a question, I can hold on. I wanted to ask about the cooling system because that's so big for you guys. And we were just we just had a review of how we do inspections at my company, and we were reviewing the cooling system. And I'm just wondering, what do you guys do to make sure that the air conditioner is working properly? Because kind of the standard thing that most home inspectors do is you measure the temperature of the air going into the system and the measure of the temperature of the air going out. And then you go, okay, yeah, it meets criteria. But it just seems like it's such a crappy test. And there's so many variables that you're not taking into account. What do you guys do in California where this is so big? You got to be doing something much better than us.
Well, I don't know. I think you made a presumption that might not be true, because the bulk of California, San Diego, is coastal. And when I lived in Oceanside, which is coastal, I didn't have cooling. You know what our cooling was? Open the window.
Oh gosh. Yeah.
Which a lot of people don't do anymore. I can't tell you how often I go to inspect. People just don't open windows anymore. So a lot of the coast doesn't have cooling because you don't need it. But certainly midway, once you start coming inland, especially where I am, which is about 30 miles inland, you definitely need cooling. So as far as inspecting it, most inspectors are still doing the temperature differential test. So that's the standard test here as well. Now I like to run the cooling for almost the entire inspection and make sure it's operating properly. I like to feel the temperatures of the gas and the liquid line. That's another measurement that you can do. Although I don't use instruments, I just use my hand, so it's not all that scientific. And I do take a temperature differential test, but I do it as close to the air handler as possible. Because the further away you get, the more heat gain you're going to get, which is going to throw off that measurement. And remember also, if it's humid, you have to wait at least an hour before you do that because the system has to remove the latent heat that's in the air. You got to get rid of the moisture before it can start dropping temperature. So, there's lots of good. And here's the other real simple test: is to put your hand over the top of the condensing unit. If the air coming out isn't hotter than the ambient air, it's not working. So, there's some pretty simple, pretty simple tests we can do. But that's pretty much the standard here, is to do the temperature differential. But when I'm teaching, I tell inspectors, you got to get as close to the air handler as possible to get a proper test. And that's not always, indicative that the system's going to operate properly. We have to warn people about refrigerants that are outdated, that are no longer going to be available, and your system is going to be obsolete. We have airflow is another issue. Duct leakage. If I'm inspecting a house and I open the attic hatch and that nice cool air comes down on me, fabulous for inspection. But I know I got a lot of more duct leakage than there should be. So things like that is what we're looking for. Now, new construction homes today, at least here, have to pass a building envelope test where the duct leakage can't be more than 5% of the air handler cubic feet per minute flow. So there's outside what's called third-party testing required in new construction here in San Diego County, where duct leakage is limited to a certain amount because that's the biggest factor. People were leaking the conditioned air in the attic or in the crawl space, and it's not going in the house where it belongs. So that's a big problem with cooling and wasting. We're wasting a lot of energy because of that. So we find a lot of duct leakage, even in new construction.
Sure. And, one other question about checking the temperature differential. What is an acceptable difference for you?
Well, for me, and it's going to sound a little low. I'm good with about 14 to 22 degrees differential because older homes are probably going to be a higher differential because a lot of systems are oversized.
Yeah.
But there's, now actually the requirements are you got to calc that system and use manual J and manual D from SmackDown and get proper sizing. So if you've got, and the best air conditioner or cooling system is going to run longer and less often. So many times, and we used to actually reduce the size of the coil in the house. This is years ago when I was plumbing mechanical contractor, to make the thing run longer so that it was more effective at removing humidity. Because in Connecticut, that's what the big thing was humidity in the air, made you feel hot. So you want your system to be properly sized, and it should run long periods, less often. You get an oversized system, it's going to come on, satisfy the thermostat, shut off. But it won't remove the latent heat that it needs to remove, if that makes any sense. But,
absolutely. We've talked about that quite a bit on this show.
So, so lower temperature differentials are going to be expected because the system should be more accurately sized to run longer and less often. So it's not going to, create this huge differential. it's going to be better at removing latent heat, which makes you feel more comfortable as an occupant.
Sure. And if you do a test and you get a really high temperature differential, say 30 degrees, what are you going to tell your client to do about it?
That's airflow.
Okay.
Almost always. Or it's, improperly, well, it could be too much refrigerant. It could be a lot of different things, but almost always that's improper airflow. So not enough air is getting over the coil. So you're getting a high temperature differential. And it could eventually result in a freeze up of the coil.
Yeah.
It's too cold.
Yeah. And that could be caused by improperly sized ductwork. You don't have enough supplies. Maybe somebody shut off a bunch of supply registers. Maybe you got a filthy filter. Maybe you got a clogged evaporator coil. It could be a lot of stuff. Right?
Yeah, dirty coil. And here's the number one cause is a lot of times in older homes, 60s, 70s, maybe even 80s homes that had heating only, and they add air conditioning to it, but don't change the ductwork. So you've got the old ductwork that was sized for heating only. And you need to upsize for cooling because it's more dense and harder to move than warm air. So if your ducts aren't big enough, obviously you're going to have an airflow issue, which is going to cause that high temperature split. We see that a lot where there's older homes where it was heating only and they put in air conditioning and the ducts just aren't big enough, so you don't get proper airflow.
Sure. Okay.
We have that issue too in the Twin Cities. A lot of older houses that just had heating and then they add AC and there's not enough supplies or even a return in the upstairs to help with that as well. So,
well, if you'll notice when you change, a furnace or an air handler to a newer one, you typically have at least, even on the less expensive models, a 2-speed fan motor. And the reason is because the cooling requires a higher fan speed. You got to move, more air, and it's denser air, so it's harder to move. So that fan speed kicks up higher than if you were using that furnace for heat only. So you got to have bigger ductwork. Otherwise, it'll work, kind of, but not as well as it could or as efficient as it could.
In terms of like cooling systems, what do you primarily run into out there? Am I just like a standard, electric like AC system? Are you running into a lot of heat pumps or what do you have?
Gosh, probably 90% of what we see is going to be natural gas or propane gas furnace with air conditioning. Now, with the electrification requirements that California is going through now, heat pumps for both heating, space heating, and also water heating are becoming much more common. In fact, in brand new construction during plan check now, you have to show that even if you put in a gas furnace, you have to be electric ready. So there has to be a circuit there for the eventual replacement with an electric appliance. So all of California is getting ready for electrification. And then, of course, there's issues where apparently gas cook stoves are bad for us to have them in your house. We even have to have bigger hoods over gas ranges now rather than, as compared to electric. I don't know if that's where you are, but, just some things that you would never think of all of a sudden are coming up. So, but typically gas furnace with air conditioning is what we see here.
Okay. Well, that's interesting because we have talked about kind of the potential health impact of having a gas cooktop that's venting back into your house without having adequate exhaust ventilation or kitchen exhaust for it. But here, in Minnesota, it's not a requirement to have kitchen exhaust ventilation, and a lot of houses don't, and they cook with gas. And personally, I've lived in houses like that, and I've had a little personal CO monitor that I've kept on me or in the kitchen to monitor that. And it's amazing how much carbon monoxide you will get in your house from just cooking something in the oven or using the burners. And so adequate ventilation is, California is obviously there's a lot of regulations more so than in other states, but that's one I can get behind. Honestly, and we're not even talking about fine particulates too.
Right.
Yeah.
Well, kitchen exhaust, kitchen ventilation is a requirement in California, regardless of what fuel is for your cooktop and your oven.
Smart.
Now, and speaking of the carbon monoxide, the personal detector, I wear one on every home inspection. I wear a personal CO detector that clips onto my belt, and I wear that during the inspection. And over the years, I think twice. Does yours vibrate? It'll start to vibrate and then make noise.
It flashes. Yep.
Right.
Yep.
So it's gone off on me a couple of times, and most of the time it's been where I'm standing in a mechanical room and I'm checking. I've got all the appliances running, and something's wrong. There's not enough air getting in, and it'll go off, or the vent was clogged or something like that. But that's it. I would recommend all inspectors and technicians, if you're working in somebody's house, especially in a confined space, you want to wear a CO monitor. And as soon as it starts to vibrate, you get the heck out.
Yes. Good tip, Mike. Good tip.
As you were saying, the cooktop, when there's nothing, or gas cooktop, when there's nothing on the flame, you tend to get no CO rating or CO readings. But once you put a pot on, that impinges the flame. So it's in the flame. So that's when you start producing a little bit of CO typically. And sometimes you'll even see soot on the side of the pot. That means you're creating carbon monoxide. That's what soot is. Soot is always a factor when you're creating carbon monoxide because of flame impingement or improper combustion air.
Yeah.
So where you're at, is the building code requiring balanced whole house ventilation then as well? So you're seeing HRVs or ERVs in all the new construction?
We don't see ERVs or HRVs. I know that our requirement is the ASHRAE requirement, which I think is 15 cubic feet per 100 square feet of floor area, or like 0.35 air changes per hour is pretty much what it's supposed to be in the entire house. So what we're doing is the ERVs, HRVs are kind of expensive, and we don't have the extremes in temperature here to really warrant that. What we do is pull in outside air. So we'll have the system designed so that when the HVAC is running, it's pulling in outside air. Now, sometimes there's an intake fan, sometimes not. Usually it's just connected to the return side of the furnace. So whenever the furnace is running, you're going to be pulling in outside air. And then most of our ventilation, the air out, is through fans that are connected to humidistats. Some are on timers, but most of them are going to be like in bathrooms, and they're automatic fans. They don't give you the choice to turn the switch on and off because people aren't going to turn it on. Well, people won't use it.
Yeah.
And they don't open the window either because it's cold. So it operates on a humidistat, some of them on timers. And those are required now too.
Okay, that's very interesting. So just that the fresh air being pulled in through some sort of passive duct that ties into the ductwork of the furnace.
The return air. So when the return
air,
it's sucking the air in mechanically. And it should be through a filter.
Oh, and you got a filter for that. So it's not really entirely passive. I mean, we've got that on a lot of our old houses, Tessa, and we'd always call it the combustion air duct connected to the return plenum is kind of how we describe it. And what ends up happening.
Yeah, it's an outside, not makeup air, but outside air intake.
Yeah.
And we also require makeup air in like a laundry room for the clothes dry. Because that's sucking a whole bunch of air and competing with everything else in the house for air, including the occupants.
Sure.
Yeah.
And so what happens in Minnesota homes is you connect that return duct to your duct that goes to the outside. And every time your furnace blower fan kicks on, you're bringing air into the home, you're pressurizing the house. But for every cubic foot of air that comes in, a cubic foot of air is going to leave. It's going to get out somewhere. And what we end up happening with a lot of Minnesota homes is it forces that air up into the attic space. And because that's traditionally the most leaky area. And then we end up with frost issues and all that. And it all gets exacerbated when you've got that return duct connected to the outside. Do you have ill effects on your houses when you guys do this, or is your climate just so neutral that it just kind of works?
I think so, Reuben. I think because it's so forgiving here. Now, the big thing too is the requirement for air sealing, because we never did that before. And the requirement for air sealing, in particular, penetrations up into the attic, penetrations of the top plate, recessed light fixtures all have to be airtight models now. You want to limit that airflow because you are going to pressurize the house a little bit when you're pulling in this outside air, but you want to try to prevent it as much as possible of it getting through stud cavities and out through recessed lights and that kind of thing up into the attic. So that's never good. Colder climates, it's even worse because it brings humidity from the house up into the attic, which causes frost and condensation on sheathing and all kinds of other stuff. So that's pretty much what we're doing here.
I'm curious, Mike. So that air that's coming in for the fresh air and mixing with the household air then through the air handler and being distributed through the ductwork, you said it runs through a filter, but I'm just curious, with the forest fires with the forest fires that California has and, the outdoor air quality concerns, is that an issue with this type of ventilation system?
Well, just like opening the window, certainly it could be. Some of them operate with dampers, but they're not available for readily to the occupants to change it. So we do have some requirements. If you're in a certain fire zone, there are some other requirements like fire dampers, like we have to have automatically closing attic ventilation. So your soffit vents, when heat hits them, they close up so that we're not allowing the hot embers up. I know. You think that adds a little cost?
Yeah, no kidding.
Yeah.
Wow. Batten down the hatches, hit a button, all your soffits close. Yeah.
Well, no, it takes heat. So, but that's just some other requirements here. But it depends upon where your house is being built. There's different requirements in different areas. And that would be the more, the areas where there's lots of vegetation and so on, where it would be prone to fire damage. We also require fire sprinklers in new construction.
Okay.
So inside the house, which actually we really need the fire sprinklers outside, but inside the house is protected by fire sprinkler systems too. That's a requirement here.
Okay. And you mentioned something.
Go ahead, Tess.
Go ahead,
I'm just wondering when did the fire sprinklers come into effect?
Oh gosh, it depends. San Diego County, I remember doing an addition in 1990 or so, and it was required.
That's a long time.
A long time. Mm-hmm.
Okay, got it. Thank you.
Interesting. You mentioned, HERS scores before and just some of this new air leakage requirements. What is required for a new house today? Does it have to have a HERS rating, and does it have to have a blower door test? And if so, what's the air change per hour rate?
Okay,
that's required.
It depends.
Okay.
So when you get a house plan check, you have to comply with what's called Title 24, which is our California energy requirements. Now, you have to meet a certain score, and you get credit for certain things that you do with the house. So you don't have to do, to comply with all the requirements. You just have to meet a certain score. So, maybe you don't want to use a certain U rating on windows, where you can get around that by installing insulated draperies.
Right.
So, there's things that you can do to offset. And there's a whole separate industry here of Title 24 calculation firms. So when you get your plans done, you send it to them, and they make sure you comply by going through all this, Title 24 calcs is what we call them. It's the energy code of California. But one of the requirements for indoor ventilation is that I think 15 cubic feet per hour in the habitable space.
Okay.
So 0.35 air changes per hour is what we're looking for fresh air in the house. That's pretty standard here in Southern California. Now, the ways that you do it are variable. So there's not just one way to do it. You've got many different ways of complying with Title 24.
Yeah.
And that's a separate company because it's so freaking complicated.
Yeah.
That's a separate profession. And yes, the ductwork has to be you have to do a blower door test and meet a certain score. And part of that score is duct leakage.
Yes. Okay.
Of course,
That's
there's
kind of what
leakage around
Minnesota.
windows, leakage
Yep.
around doors, and all that kind of thing too. They use smoke and calculations to find these air leaks.
To make sure. Yeah. It's the same thing for Minnesota. We, have required blower door testing and a certain air changes per hour for building envelope air leakage for a while, and duct leakage testing, and mainly just in houses. It used to be houses that had ductwork located outside the building,
the
thermal boundary.
Building envelope, right, it's not required. Which that's that's what we're seeing now, is we're making the attic, and in some instances the crawl space, part of the building envelope. And then you don't have to worry about duct leakage because it's leaking into the conditioned area.
Right.
So what?
Yeah. Well, actually, so that's a perfect segue into. I had a question about attics. Can you talk to what you're seeing in terms of attic insulation where you are, especially with a lot of the ductwork being located probably up in the attic because you don't have basements or you may not have a crawl space. Do you see a lot of hot roofs out there?
It's we have a certain requirement for reflectivity of the roof material. We have to have cool roof rather than hot roof. So
maybe the better question would be, where do you see the insulation installed? Is it across the attic floor or is it up against the roof deck?
Well, and that's an interesting, we can put it across the floor. However, there is a requirement now for a minimum layer of insulation on the underside of the roof deck. And you're also required to have a radiant barrier.
Wow.
I know. So,
wow.
I'm shocked by this. There's a requirement to put insulation up on the roof deck. So why would any builder put it up on the roof deck and on the floor of the attic? That's confusing the conditioned living space, in my opinion.
Well, you have to have a certain R value. Now, the reason for the insulation under the roof deck is to prevent or help prevent the radiant heat from that roof be radiated into the attic, which makes it warmer.
Solar heat gain.
Right, but you also are required to have a radiant barrier, which most of the time is going to be roof sheathing with the aluminum, like the foil, already on it.
Yep.
That's the way it gets done. So I'm not seeing a total conversion to foam. Like you're seeing it a lot, like Florida, Carolinas, and so on. A lot of their attics, there's foam sprayed all over the underside of the roof. I'm just not seeing that here yet. They're still using, like an R30 something on the ceiling joists between, above the ceiling. And then we've got to have that insulation under the roof sheathing. And that's mainly for helping to prevent the thermal gain from the roof that makes the attic hot.
Sure.
Okay,
and increases
so it's a
the
minimal
load on
amount.
the cooling.
Yeah. Okay. So usually the ductwork then is kind of sitting up above the insulation, typically, is what you see.
Yeah. But we require a certain amount of insulation around the ductwork. Plus, we've got to have that minimum, that maximum. I think it's 5% of duct leakage. So that's pretty tight ductwork. It used to be, I think, 3%, but that's like almost impossible. So now it's 5%.
Well, because of the requirements, I guess, with your building code, I'm sure the installers, the HVAC people who are putting the ductwork in these attics that are outside the thermal boundary are getting pretty good at what they do and making these systems pretty tight, it sounds like.
Right. Well, it's a requirement, and it's going to be tested, so you kind of have no choice. And if it doesn't,
you have to do it.
You got to fix it, and you have to retest, which costs you money. So if you're an HVAC contractor, you want to get that thumbs up first time around.
Because
it'll just cost you more. So why do that?
So do you have any problems with condensation or moisture in attics or in ductwork or anything like that where you are?
Well, we can with ductwork, mainly if it's in the crawl space. I've seen that.
Okay.
Where there's condensation in a cold, humid crawl space. And most of that moisture is coming from the soil. And we've had issues with condensation. And a lot of it has to do with damage to the insulation on the ductwork itself because it gets chewed by vermin or people crawling around, knock it off and create a cool surface for the humidity to condense. But it's not a big, huge problem here. Most crawl spaces we go in are dry. unless there's a plumbing leak.
That's nice.
Or drain. Yeah. It is. It is. It's pretty rare to find a crawl space with water in it here.
Yeah.
That's amazing. So what are some typical like problems that you might be looking for when you're inspecting a house where you are?
Everything.
Like top three problems you see.
Top three. Well, pretty much while I'm in the car, before I even see the house, the filters are dirty. There's soil too high on the outside wall, and it's covering the weep screed of the stucco. So that's where the bottom of the wall is where the water gets out, and it needs to be unimpeded. And a lot of times what happens is people will install masonry pavers or even concrete, and they terminate it up above that weep screed at the bottom of the wall. Now, we don't have a whole lot of EIFS systems here, but we have a lot of traditional stucco. And in either case, where does the water come out? The bottom of the wall. So if you cover it up or encapsulate it in concrete, it doesn't work too well. And we see that a lot here. So filters, and then roofing issues. We have a lot of fragile roofs here, concrete and clay tile, and almost every one is going to have broken tiles or tiles slipping off, some kind of issue with the roof. So those are probably the big items. I find air conditioning not cooling properly quite a bit, mainly because of lack of maintenance, older systems, I think. And then people don't want to spend the money. These are older, like R22 systems, where it's expensive, and it's eventually we're not going to be able to use it. So those are probably the big things. Drainage, too. Drainage around the house is always a big thing.
Always.
For these roof systems, like for say clay tile roofs, do you walk those?
Oh heck no, I'm too big. So it's I wouldn't recommend anybody walk a clay tile roof in particular, because the roofers that work on these, they have special equipment to walk on it. They use sandbags or they use these wood walkers. So they like a piece of plywood that spans 3 or so rows of tile. So you distribute the weight. And I've seen them use, like I said before, sandbags to walk on. But
what does a sandbag look like? I've never seen that.
A sandbag. It looks like
a literal sandbag.
Yeah.
Okay. All right.
Yeah, got it. So, and there's other methods as well. But clay tile roofs, I don't walk it myself. What I do is put up a ladder, different areas around the eaves, and that's how I inspect the roof, or with a pole camera. Some inspectors use drones, and that's fine. I'm an advocate of being safe. So you don't want to walk. Now, some concrete tile roofs I will walk on if they're flat, what we call shake tiles. I'll walk on those. Okay. Sometimes, depending upon the slope and whether it's got lichen growing on it or something that might be slippery.
Yeah. All right.
Yeah.
That makes sense.
Okay. Well, I know we're running short on time, but I have one more question I want to ask you, Mike, before we wrap it up. So, quick when you're having fun, hopefully. Us house nerds, we could talk about this stuff all day, right? So, okay, my last question is, I'm wondering, are the insurance companies out where you are impacting how you're doing inspections and what type of inspections you offer and issues that you're seeing with buying and selling houses? Because we've kind of touched on that with several other guests on our show. I'm just wondering what you're seeing out in California.
Well, I guess it depends upon whether you're talking about hazard insurance companies or home inspector insurance. So I'm going to presume we're talking about hazard insurance.
Yes. Yeah, for a homeowner. Mm-hmm. Right. Yes.
Yep.
Well, the big issue here is fire. And, a lot of people have been dropped by their insurance company and have had to go to the state exchange, which is pretty expensive. Now, as far as our inspections, it doesn't really affect us all that much, other than we're seeing new systems and components in newer homes, or maybe even being retrofitted, such as closable attic vents, which help prevent the hot gases from getting into the attic. Some people are installing roof sprinklers, irrigation systems, basically, but it's a sprinkler system. We're seeing some new products out there where they can flood like around your house with a fire retardant foam or something. So there's lots of there's lots of cool things coming up. Really the only thing I've been seeing is the attic vents that automatically close and what's called house hardening to help prevent those hot gases from getting in. If you've got crawl space vents, they'll close automatically if there's heat. You want to have that defensible area around your house where there's no vegetation or dead vegetation mostly. So things like that we're seeing, but it's not really affecting us. Not like it does in Florida where they have to look for hurricane clips and impact and just so many different things. We're not seeing that.
Yeah.
Yeah.
Huh.
Okay.
Interesting. Did you say there was a sprinkler system that houses have on the outside that sprays like a fire retardant foam? Did I hear you right?
Yeah, that's another system. Some people, I have seen water sprinkler systems installed on the roof where they'll water the whole house down in the event of a fire, but you might not have water. So, it just depends.
Right. Wow, that's fascinating. Okay, so homeowners are still able to in general find insurance providers who will cover them with the standard housing stock that's out there.
It's a little more difficult. It's definitely much more expensive. I've seen my rates. Let's see, this house we bought in 2017, rates have tripled since we bought it. Yeah, I know. That's what I said.
Wow.
I more said,
yikes.
But it's nowhere as like Florida is definitely more expensive for homeowners insurance.
Okay. Yeah.
We're getting there because
very interesting.
You've probably seen in the news where there's certain carriers have just left the state. They're like, "Yeah, we're done with these Californians."
Well, and that's what's happening, I think, in a lot of places around the country that have a lot of natural disasters and, claims is that, that's the challenge, challenges that we're facing right now. And it's affecting everybody's insurance costs.
Oh, yeah. Yep. That and fraud. But, that's not much we can do about that.
Yeah. Wow. Well, we touched on a lot of topics today, Mike. Thank you so much for being here and just for the wealth of knowledge that you are willing to share with us. And I could ask you a million more questions, but this podcast has gone on for almost an hour, so we should probably wrap it up. Was there anything that we missed talking about, either Reuben or Mike, that you want to touch on before we sign off?
No, I had a blast. It was great. It's like one of the fastest hours I've ever been through.
Awesome. Well done, Tess. Good question.
Good job.
Yeah.
Well,
Mike,
thank you.
You're always a delight to listen to.
Well, thank you.
I appreciate it.
It was fun.
Yep.
And you'll get to listen to me again soon.
Can't wait.
Yeah, I'll see you.
Where is this going to be at? Where will people hear you again, Mike?
Oh, Reuben and I are on a committee together. So we get to talk.
Oh, okay. I thought you had some upcoming classes.
We spent a lot of time chatting.
Yeah.
Yes.
Got it. Okay. Wonderful. Now, if listeners have questions, Reuben, how do they get a hold of us?
Please email us podcast@structuretech.com.
Thank you. Thank you for that.
I'm glad I could help, and we'll catch you next time. And we're going to be having another professional come on with another area of the country.
Perfect.
We'll catch you next time.
So stay tuned.
Have fun.
Yep.
Okay.
All right.
We'll see you.
Thanks.
Take care.